Okay, so here we go on this question. It says we have a bag of marbles, 4 red and 8 blue. Everybody has different numbers. So this one is going to be random. Everybody has different numbers. We randomly pull 2 marbles with replacement. Find each of the probabilities. Now down here, notice it says the same thing, but it says without replacement. So let's talk about that right now, and then we'll get into the details. So with replacement, what does that mean? That means step 1, you'll pull out your first marble, record the color, replace it in the bag. And then step 2, pull out the second marble and record its color. Okay. Whereas down here, so that's with replacement. Down here, it's without replacement. So that means step 1, pull out the first marble, record its color. Do not put it back. Do not put it back in the bag. Don't put it back in the bag. Step 2, pull out the second marble. Pull out the second marble and record the color. So that's the difference. The difference between these two parts is in part 1 up here, we are replacing it in the bag. We're replacing the first marble, putting it back in the bag. After we look at it, record its color, we put it back in. So when we reach into the bag the second time, it's the exact same group of marbles it was the first time. We put it back. Whereas down here on the second time, it's going to be harder because we're not replacing the marble, meaning we pull it out, we don't put it back. So when we reach in the second time, there's a different group of marbles. There's one less marble in there. It's going to change the probabilities a little bit on the second pull. So we'll get to that. So let's start up here with this first part up here. So I'm going to draw a tree, right? We always make a tree whenever we have more than one action, like 2 coin flips or 3 coin flips or 2 dice rolls or 2 times pulling marbles out of bags. Anytime there's more than one action, we make a tree. So I'm going to make a tree. So I'm going to come down here. I'm going to say, okay, so first pull out of the bag, we're going to get either what? Either a red marble or a blue marble. First time we reach in the bag, we're either getting a red or a blue. And then second time we reach in the bag, pretty much same thing. We're either getting a red or a blue. Red or blue. Okay, and what are the probabilities? Well, we have, isn't it 4 red, 8 blue, or do I have that vice versa? I can't remember. Yeah, I got it right. 4 red, 8 blue for mine anyway. Mine's 4 red, 8 blue, and this is with replacement, meaning we're putting back the first marble. So anyway, what's the chance of getting red? 4 out of 12. What's the chance of getting blue? 8 out of 12, right? That makes sense so far. So we have a total of 12 marbles, right? Let me add that up. Adds up. 12 total for mine anyway. There's 12 total marbles in the bag. So when we reach in the bag, the chance we're going to get red is 4 out of 12. 4 red out of 12, and the chance of blue is 8 out of 12. So this is the first draw. Here, let me write it. This is the first draw, and this is the second draw out of the bag. Okay, second time we reach in the bag, well, it's the same. 4 out of 12 for red, 8 out of 12 for blue. 4 out of 12 for red, 8 out of 12 for blue. Why? Why is it the same? Well, because we replaced it. So whatever marble we got out the first time, we recorded the color, but then we put it back. We replaced it. So it's the exact same group of marbles. There's still 12 marbles. when we reach in the bag the second time, exactly the same number of marbles, same number of red, same number of blue. So it's all the same. The second branching is identical to the first. That won't be the case when we get to part 2, but it is for now. Okay, so then what? Well, now the results. Right, you just do the equals. And remember what you do. You move from left to right. Remember how these tables work. You always move from left to right. So the first entry is red, then red. So red, then red. The next one is red, then blue. Blue, then red. Blue, then blue. You tracking with me? Red, 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 red. Red, oops. Red, blue, red, blue. Blue, red, blue, red. And blue, 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 blue. You tracking, you move from left to right. Now, what's the probability? You multiply. So as you go 4 twelfths, red, red, then you multiply those together. I'm going to do that. 4 twelfths times 4 twelfths, which is 16 over 144. Now, in this question, they specifically say reduced fraction. So they want you to reduce all of your fractions. No decimals, and the fractions must be reduced. So how do you reduce? Well, you remember all the reducing stuff, right? Just use your calculator. Some of your calculators will do it for you automatically. Some of them you'll need to do it by hand. Let's do it by hand here. This comes out 1/9. So the chance of red, red, 1/9. Let's do the next one. Again, it's from left to right. So it's red, blue, red, blue. Multiply 4 twelfths and 8 twelfths. See how I'm moving from left to right through the table to get to the result, red, blue, which is 4 twelfths times 8 twelfths. 4 twelfths times 8 twelfths. Which is 32 1/44, and then you reduce that fraction. Again, for me, it's divided by 16, top and bottom, which will be 2/9. That's the chance of red then blue, 2/9. Okay, down here, now blue then red, again, move left to right through the table to get blue, red, 8 twelfths times 4 twelfths. Which is 32 1/44. Divide by 16 again, 2/9. And finally, blue, blue, as you move from left to right through the table, blue, blue, 8 twelfths times 8 twelfths. Oops, that's not 16. We're multiplying, not adding. I just added there. 64 over 144. Divide by, don't know. Divide by something good. 16, I think. Top and bottom, you get 4/9. There we go. All right. So we did the whole table. Let's go up now and answer their questions. Once you got the table, the tree, the questions won't be too bad. Both marbles are red. Red, red, right here. Red, red, 1/9. Yeah, okay. So that's 1/9. Next question. Both are blue. Blue, 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 blue. 4/9. Two marbles of the same color. Same color. There's a couple ways to do that, huh? Same color could be red, red, or blue, blue. So it's 1/9 and 4/9 added together. So let me write that. So it's red, red plus blue, blue, same color. So that is, again, what was red, red? Let's go back. Red, red, 1/9, blue, blue, 4/9. 1/9 and 4/9. Which is 5/9. Same color. And now last question is different colors. So different colors could be red, blue, or red first then blue, or blue first then red. Tracking with me? Right, different colors means red first then blue, which is 2 9ths, or blue first then red, which is also 2 9ths. Got to add those together, 2 9ths and 2 9ths. So whenever the question has a couple of possibilities, you have to add those together. So that'll be 2 9ths and 2 9ths, which is 4 9ths. All right, so there's part 1. That's the easier part. Now for the big, the bad, and the ugly, part 2. Part 2 now, we're going to pull out 2 marbles to stay back without replacement. So that's where things will get more interesting. So again, we have 4 red. Let me go back. 4 red, 8 blue, 12 total. And this is without replacement, meaning do not put back the first marble. Do not put back the first marble. So that's going to change the game quite a bit. Okay, so here we go. So first branching. First branching again. We get, I'll make this too long. We get a red or a blue marble. Second branching, we also get a red or blue marble. Okay, so now what are, and then we have the results. I should write those in first off. The results over here. Red followed by red, red followed by blue, blue followed by red, blue followed by blue, right? So, okay. So now, what are the probabilities on the branches? Well, down here, this is the first pick, and this is the second marble we pick. So for the first pick, you know, red is just 4/12, and blue is 8/12. That makes sense, right? First pick, you have 12 total marbles in the bag. 12 total marbles in the bag. 4 of them are red, 8 of them are blue. So the chance you're going to get red is 4 out of 12. 4 red marbles out of 12. Chance you're going to get blue is 8 out of 12. No big surprise there. Now, where it gets a little tricky is the second pick. Remember now, we're not replacing the first marble. This is without replacement. We're not putting back the first marble. Okay, so what? Well, that means, remember, you always move through the tree from left to right. So if I go this way, I got red the first time. And now I'm asking, what's the chance I'm going to also get red the second time? Well, if you got red out of the bag the first time, now you've only got 3 red left in the bag. You with me? So your chance of getting red is 3 out of 11. Let me try to make that even more clear. Let me show what's in the bag right here. Here, I'm going to draw the bag for just extra clarity. 4 red marbles, right? And 8 blue. So there's the 12 marbles that are in the bag. Okay, so again, if you got out, in fact, you know what, actually probably better. Let me just do them right over here. Keep changing my mind. So the bag, I'm going to do the bag right down here. I'm going to say we got 4 red marbles, right? We got 8 blue. At least that's what my bag has. Every bag's a little different. You'll have different numbers. So we have 12 marbles, but if you go this road, that means you got red out the first time and you're not putting it back. This is without replacement. Do not put back the first marble. So when you go for your second draw and you're wanting to get red the second time, one red has been removed because you got that on the first draw right here and you didn't put it back. So that only leaves 11 total marbles. 3 of them in the bag are red. So the second time you reach in that bag, there's only 3 red marbles left out of 11. And what's the chance you're going to get blue? Well, there's 8 blue marbles still left out of 11. Right? 8 out of 11. Now, when we come down to this part down here, we don't go down like this. We always go from left to right. Remember, we're always, that's the key to these trees. We're always moving through the tree from left to right. So if we go this way, we're going down here, we got out a blue marble on the first draw. So if you got out a blue, cross out one of these blue, then when you go the second draw after getting a blue out the first time and not putting it back, what's the chance you're going to get red on the second? Well, you got 4 red left out of 11 marbles. Whereas if you got blue the first time and you would like to get blue again the second time, again, left to right, don't go down, it's left to right. You got blue the first time, you're wanting blue the second time. Again, you're taking out one of the blues. How many blues are left? 7 blues out of 11 are left. So it changes the probabilities, doesn't it? In the second branching, when we don't put back the first marble, there's only 11 marbles when we reach in the second time. And depending on what we got out the first time, we got red out the first time, then there's 3 red and 8 blue left. Whereas down here, if we got blue out the first time, there's 4 red and 7 blue left. You see. And now we just multiply. You know what to do, right? We're going to multiply 4 12ths times 3 11ths, which is 12 over 132. Remember, we have to reduce all these fractions. So I'm going to divide top and bottom by 12. I get 1/11. Next, so where did I get those? I went this way and this. Remember, you're always moving from left to right through the table. You're going to multiply 4 12ths times 3 11ths. And then how do you get this result? Left to right through the table. 4 12ths times 8 11ths. (32 over 132). Let me see what goes in here. Just maybe 4. Yeah, 8 over 33. For me, anyway, these are my numbers. And now down here, how are you going to get blue then red? Again, you're moving from left to right. Always, always remember, from left to right through the table. So it'd be 8 12ths times 4 11ths to get blue then red. Eight 12ths times 4 11ths, which is 32 over 132. Divide by 4, it's 8 33rds. And the bottom, again, you're going from left to right through the table. So blue, then blue. You get out blue the first time, blue the second time, blue, blue. It's 8 12ths times 7 11ths for me, for my numbers. Which is 56 over 132. For me, I divide by 4. Top and bottom, what's that? 14 33rds. So there we go. There's the without replacement, not putting back the first marble tree. Now we can use that to answer all their questions. Once you have the tree, you're in business. You're ready to go. So coming up here, both marbles are red. Well, red, red, 1/11. Right there is my reduced fraction. Both marbles are blue. Blue, blue, right there, 14 33rds, my reduced fraction. Oops. Next question. Both marbles are the same color. Same color. What's same color going to be? Well, that's going to be red, red, or blue, blue. Either one is same color, right? 1/11 and 14/33 for me. So that's a red, red plus blue, blue, which is, what was red? 1/11. 1/11. And what was blue, blue? Blue, blue was 14/33. Okay, now remember what you got to do when you're adding two fractions with different denominators. You remember. Multiply top and bottom to get a common denominator. So this will be, I'm going to have to move it over here. This will be 3/33 plus 14/33, which is 17/33. Final question. Get rid of this here. Final question. Two marbles of different colors, right? Different colors. Where are that? That's red, blue, and blue, red. Different colors. Both 8/33. So like that. Red, blue plus blue, red, which is 8/33. Plus 8/33, which is 16/33. Can't reduce that fraction. There we go. There's that answer. So we got them. We got all four answers. So the without replacement table is right there. That is a little more tricky. You don't put back the marble, so it changes the probabilities on the second draw. There we go.